So as we tilt our wave upward, we're going to get a greater lambda component, because as we increase this angle will increase, and as this angle will increase, because these two are the same angle, then this sine component of the angle will also increase. Because remember from geometry, as the angle increases, for an angle between 0 to 90, the corresponding side will also increase. And this is almost always true in a triangle, because all the angles have to either be 90 or less in a right triangle. Sorry, only in a right triangle. This is true. Because all the angles are 90 or less. So, what does this have to do with uncertainty and waves and velocity and everything? Good question. So we saw that if we have a greater wavelength, we will need a greater angle to reach the next maximum, because we only get maximums when this distance is 1/2 lambda plus n lambda, the multiple. Well, actually this formula includes multiples, so this 1/2 lambda plus a multiple of wavelength. So if we can tell that if we have a higher wavelength, we have a higher uncertainty in position, because the first three maximums are the biggest maximums, and the particle has a good chance of being anywhere there. So we can conclude a higher wavelength, higher uncertainty in position. But what about velocity? Doesn't the formula include velocity? Great question. How I like to think about it is that if you have a smaller wavelength, you have a greater frequency. And because of this formula, hf over c equals p, and h over lambda, which is h is Planck's constant, and f over c is frequency over the speed of light. So basically, energy over the speed of light is momentum. And that wasn't too intuitive for me, so I'm not going to try to explain it. But we can see that h, the Planck's constant, over wavelength is momentum, which is mv. So having a smaller wavelength means a smaller velocity. So having a smaller wavelength means a greater frequency, a greater momentum, and a greater velocity. So it kind of makes sense, like if you see a car on a freeway that's moving super fast, it's going to be hard to say where it exactly is because it's moving so fast, but it would be easier to tell the speed of it. If something's moving at 70 miles per hour, it's hard to say it's at this coordinate rather than to say it's moving 70 miles an hour. But if it's moving kind of slowly and we're not really sure what its velocity is, it's going to be easier to say it's about here and I'm kind of not sure of what velocity is. So I hope this is helpful. Let me know if I can make any changes or make this better. Thanks and bye.